Question 1. It's asking for the hyperbolic function that has a set of x that ranges from -1 to 1. So the domain, the definition of domain is how far the x values expand. So for this question, you have to know what hyperbolic functions look like. These are two hyperbolic functions given in the options. The green graph is the hyperbolic cosine graph, and the red graph is a hyperbolic tangent graph. And you have these inverse of the hyperbolic function. You don't really have to memorize how they look because it's basically a mirror image in terms of y equals x graph. So for your inverse tangent graph, for example, it's going to look like this in your first quadrant and like this in your third quadrant. And if you remember the asymptotic line for your hyperbolic tangent graph, it's -1 to 1. So if you inverse that in terms of y equals x, it means that your x values ranges from -1 to 1. So therefore, the answer is inverse tangent hyperbolic function. Question 2. The question is asking for the Maclaurin series expansion that has first two non-zero term, x and -half x cubic. In your formula booklet, there will be different Maclaurin series expansion for different functions, for example, exponential, natural log, sine, and cosine. For this question, you're going to use these three particularly. So if you look at this first option, it has exponential of half x squared. So you're going to substitute half x squared into equation 1, which is exponential Maclaurin expansion. If you do that, the expansion for the exponential graph is 1 plus half x squared. Because we're gonna substitute this x with half x squared, this is going to be half x squared. And then afterwards, the power of the x gets higher than 3, which is given in this question. So we're not gonna look into it and then just skip as ... And we have this x in front of the exponential function. So we're gonna multiply x to entire function. So 1 becomes x, and half x squared becomes half x cubed, and then everything else has higher power than 3. In the question, it's asking for x and -half x cubed, therefore it's not the correct answer. You did a similar thing for this second option, but with sine graph. So we're going to substitute 2x into equation labeled 2. Then our sine 2x will expand as 2x minus 2x cubed and 3 pictorial. It becomes 2x minus 8x cubed over 6, because 3 pictorial is 3 times 2 times 1. And then this becomes 2x minus 4x cubed over 3. And then we have this half term in front of it. So if you multiply 1/2 into that entire function, it will become x minus 2/3 of x cubed. Again, this is not what question is asking for. And then our third option is cosine x. It's simple because it's just a cosine x as is given. Therefore, we're just going to multiply x to that function 3. Then it will give you x minus x cubed over 2 pictorial. X minus x cubed. 2 times 1 is just 2. Therefore, this is exactly what question is asking for. Therefore, the correct answer is x cosine x. Question 3. This question is asking you the mean value of the function from x is -0.5 to x is equal to 1.7. In order to solve this question, you have to memorize this formula where the mean value of certain function is 1 over b minus a times by the integral from a to b of the function given. For our case, the limit, which is a and b, is negative 0.5 and 1.7. So if you substitute these values, it will give you 1.7 minus 0.5. Integral range from negative 0.5 to 1.7, and our function is x squared minus 1. Then the fraction in front of the integral becomes 1 over 2.2. And then the integral of the x squared is 1/3 x cubed minus 1 is x. Integral is x, and that ranges from 1.7 and negative 0.5. So if you solve this integral by substituting 1.7 and negative 0.5, you get negative 0.237 as your answer. For this type of question, you have to set the arbitrary z value. So let's say we have x as our real value and y as our imaginary value. So let's say our z is x plus yi. Then our conjugate of that z that we set is noted as z star. It should be x minus yi. So the sign of the imaginary part just changed for your conjugate. Now we're just gonna substitute our z and z conjugate into the given equation. It's 2 times yx plus yi minus 5i. Careful with your sign and the bracket here. X minus yi. And that should be equal to 12. So if you just expand this bracket, it's 2x plus 2yi minus 5xi. I swap x and I for the convenience for the next steps. And then we have plus 5y, and then I times I, which gives you negative 1. So that's 12. Now we're going to combine all the real terms. Real term meaning the terms without the I. So that's our 2x and our 5y times minus 1. And then the imaginary part is the opposite one. We have these two terms as an imaginary part. So if you combine the real part and imaginary part together, it's 2x minus 5y plus 2y minus 5x, and then I put the I sign out of the bracket just to make it easier to see, and that's equal to 12. So that means that imaginary part has been gone. So this is 0i. So we have two equations here. This part should equal to 12 and the imaginary part should be equal to 0. So 2x minus 5y is 12 minus 5x plus 2y is equal to 0. So if you multiply 5 to your first equation and 2 to your second equation, so multiply 5 and 2 to your equation, then it becomes 10x minus 25y is equal to 60. And if you multiply 2, that becomes negative 10x plus 4y equal to 0. And then you add the two equations together to make minus 21y is equal to 60. So your y is 60 over minus 21. If you divide by 3, it's minus 20 over 7. Now we find the x. Either you substitute into 1 or 2, then you'll get x is equal to negative 8 over 7. Therefore, your z value, again, was our x plus yi. So our x is minus 8 over 7. And then our y is minus 20 over 7. And then don't forget your imaginary I. That's our answer. Question is giving you the equation for the plane and the line. Plane follows the scalar product form, which is the vector r dot n is equal to scalar d. And then the line is following the general form of the vector form, where a certain line is extending from certain point vector p plus certain scalar vector times by the direction vector. So if you visualize this, you have a plane like this, and then the line extends from a point vector p with the direction vector D. So this is P and the direction vector D given in your line vector form. And then the plane has a normal vector. The normal vector is always perpendicular to your plane. So your n vector would look like this, where it goes perpendicular to your plane. And then the question is asking for the angle in between the plane and the line, which is here, the theta value. But we only know the vector d and n here, so let's start from the angle between your normal vector and the direction vector, and then we'll just call that theta prime. So if you use the definition of the dot product, it's your d dot n is equal to the size of your d vector and size of your n vector times by cosine theta prime. We use theta prime here because it's the angle that's surrounded by your direction vector and your normal vector. So if you rearrange your equation in terms of theta prime, it becomes d dot n over the size of d times by size of n. And then you're gonna arc cosine that to get your theta prime value. So let's start with the dot product. The direction vector in the line is 1, 0, 1 dot with the normal vector of the plane, which is 1, 1, 1 given in here, 1, 1, 1, and that's gonna give you 1 times 1 plus 0 times 1 plus 1 times 1, which becomes 2. And then what's the size of our direction vector? So size of vector 1, 0, 1 is square roots of all the components squared. So that's square root 2. And your normal component 1, 1, 1, again, that's 1 square plus 1 square plus 1 square, giving you square root of the 3. So if you substitute all 3 into the equation that we got, our theta prime is arc cosine 2 over root 6. But remember, we're not looking for theta prime, which is the angle between your direction vector and the normal vector. Well, we have to get the correct angle that's asked in the question, which is the angle between line and the plane. So we want this theta value. So to get that, theta is 90 minus theta prime. So that's gonna be 54.7 degree. For this question, you first have to know the definition of the hyperbolic function, which is written in the first line here. And then you also need to know, but not memorize because it's in the formula booklet, about the binomial series. For this question, they're asking for the power of 3, so let's substitute n equals 3 into the binomial series, which gives you a plus b to the power of 3 becomes a 3 plus 3 choose 1, a n minus 1, so it's squared times by b plus 3 choose 2, and then a, b becomes squared, and then now a is get removed because 3 minus 3 is 0, a to the power of 0 is 1, so now b to the power of 3 is our last term. And then a to the power of 3, 3 choose 1 is 3, and again 3 choose 2 is also 3, and then b to the power of 3. It's actually better to actually memorize these to make your life easier, and then you can solve the question much faster than before. So that's good to know. And then now we substitute both sine h and cosine h into this binomial function, the highlighted one. So if you want to find the cosine h x power of 3, then it means e to the x plus e to the pi minus x to the power of 3, and then the denominator becomes 2 to the power of 3 as well. And then the first term, let's substitute into our general form. Then it becomes e to the power of 3x plus 3. A is now our e to the power of x, and b is e to the power of minus x. So e to the power of 2x, and then e to the power of minus x. And then the third one becomes e to the power of x, e to the power of minus 2x. And then the last term becomes e to the minus 3x. And then 2 to the power of 3 is 8. So if you do that, it becomes 3x plus, these will be added up together. So it becomes 3 e to the power of x. And then again, for the third term, we add up these two. So it becomes 3 to the power of e minus x. And then last term is just e to the power of 3x over 8. And let's do the same thing for sine hx to the power of 3. Now everything is the same, but the sign is reversed. Like that. Careful with the sign, and then let's do step by step. The first term powers by 3. It still becomes e to the power of 3x. Now it's 3 e to the power of 2x because the first term got squared, and then the b is now minus. So it's not plus here anymore. It becomes negative because of the term, the second term, and it's e to the minus x. And then the third term, it starts with 3, and our a is still e to the power of x. And then the b is now squared, so entire minus e to the power of minus x gets squared. So minus 1 times minus 1 becomes plus 1, so the sign is plus here now. But the e to the power of minus x got doubled, so it becomes minus 2x. And then the last term got cubed, so minus 1 cubed is still minus 1, so we have the minus sign at the very last term. Okay, and then the denominator is 2 to the power of 3, so it's still 8. So if you clean that a little bit, it's e to the 3x minus, again, we add up these two, power law, and then 3 e to the minus x minus e to the power of 3x, all over 8. Now we want to add these two together, so we are adding these and that together. So if you add up together, these terms will be removed, right? They're the same term, but with the opposite sign. That is left from your cosine hx to the power of 3, and then these are left. These two terms are left from your sine hx cubed term. So they're exactly the same. So we are doubling these two terms, right? And then it's over 8. If you simplify that, that's 4 over that. So if you want to make similar to what question is given here, it becomes 1 over 4 e to the power of 3x plus 3 over 4 e to the power of minus x. Therefore, our m is 3 and n is minus 1. This question starts with the term hence. This means that we have to use what we found in part A. So for this question, I copied and pasted what we found from part A, where cosine h cubed plus sine h cubed is equal to this. And then we're going to use this relation or the equation a squared minus b squared is equal to a plus b times by a minus b. So let's start solving this question with these facts. Our cosine h to the power of 6x is actually equal to cosine h to the power of 3x to to the power of 2. So why did you do that? This 3 is important because we know that we're going to use the fact from part A. So I'm just going to change the cosine h to the power of 6 into this form. So if you compare our question, cosine h to the power of 6 minus sine h to the power of 6 here, with the a squared minus b squared here, a is actually cosine h to the power of 3 and b is sine h to the power of 3. So that means that cosine h 6x minus sine h 6x is actually equal to cosine h to the power of 3x sine h to the power of x. So if you compare, this is actually same as what we found here. So we can replace that with that because they are equal. And then we have to think about what we want to do with the second bracket. So for our second bracket, we have to go to part A, where we found the exponential form of the hyperbolic functions as such. So in order to get cosine h cubed minus sine h cubed, you're going to subtract equation 1 with 2. So now we know our second bracket is now equal to 3 over 4 e to the power of x, 1 over 4 e to the power of minus 3x. So these are equal. Now we have all the exponential forms. We're going to multiply these together. So first term, second term in the bracket, and then second term, first term, second term in the bracket. So wherever the e to the power of something multiplied together, the powers will be added together. For example, if you multiply 3x and the x, it becomes 4x. If you multiply 3x, and this term, e to the power of minus 3x, you add them together, which becomes the power of 0. Everything power of 0 becomes 1. Therefore, these will become just 1 over 16 times 1. This as well, because that also has e to the power of 0 term. Therefore, this equation simplifies as such. Now the question wants this form, the cosine hx kx form. We're gonna make something similar to cosine h x exponential form, which is e to the x plus e to the minus x all over 2. In order to make that form, we're gonna combine these first two terms by bringing 3 over 8 out, and then what remains is 2 over e to the 4x plus e to the minus 4x. And then we have 5 over 8. And this part now becomes cosine h 4x. Because we have power of 4x and minus 4x, it means that our cosine hx should change to cosine h 4x. So now we have this very similar to what question is asking for. It's 3 over 8 times by cosine h 4x plus 5 over 8. Now if you want to make a denominator altogether, it's 8 and 3 cosine h 4x plus 5. Therefore our a is 3, b is 5, and k is 4. And that's our answer.